Hello, I'm JW. This time we're going to have a look at cooker circuits, and more specifically what size of cable and protective device to use, and also what you're going to be putting on the end of it. Now, a cooker in the UK is generally a freestanding device which has normally at least one oven or sometimes two ovens in the bottom part, and on the top it normally has 4 electric rings on the top for boiling up water and the like. Now, so a cooker is a freestanding device. You can also buy the parts separately. Those are called an oven, which can be a single or double oven, which is a compartment you put things in to bake and cook. And then you have things called a hob, which is the top part, where you just have your electric rings to heat up water and whatever. Now, electrically, a freestanding cooker is exactly the same as a separate hob and a double oven. Just so happens that they are in 2 separate compartments rather than a single integrated appliance, but in terms of electrical loading they're basically the same deal, so it doesn't actually matter in that regard. Now we're going to have a look into the on-site guide, which we've got here, and see what it says about cookers in there, because it's another one of these things where the actual wiring regulations themselves don't actually say a whole lot. Most of the other information can be found in other publications. Now, most houses in Britain have a cooker circuit, which, if we just write that down here, this will be a dedicated circuit from the consumer unit, and it will go to generally an isolator switch in the kitchen, and then from there to some kind of outlet plate or connection for whatever appliance you happen to have. Now, in the vast majority of cases, a cooker circuit will have a 32 amp protective device, and these days that's almost certainly going to be a circuit breaker of some form. And then we come to the size of cable that's used. Now, in the vast majority of cases, people put in a cable of 6 millimeters squared, and that's been the same pretty much forever. However, would it interest you to know that 6 millimeter cable is actually, in most cases, the wrong size? In most cases, the size you can use is actually 4 millimeters squared. 4 millimeters squared being perfectly fine for a 32 amp device. Now, the reason it's still done as 6 is basically due to things that happened a long time ago. Before all of this was actually a thing, circuit breakers weren't generally used, and instead you would have a 30 amp fuse, and this would be a BS3036 rewirable type. Now, with those, aside from the rating being 30, the current rating was pretty much the same deal there. The difference with these is that you can't have 4mm on that one, because 3036 fuses have a correction factor of 0.725, which means that 4mm is actually too small for a rewirable fuse. So for those, then the cable size is 6mm squared. Now, of course, rewirable fuses are a thing of the past. There's probably quite a few still out there installed, but no new installation in the last 25 years or so is going to have used these things. Unfortunately, this size of 6mm and 30 or 32 amps seems to stick around, but in the majority of cases 4mm is absolutely fine. And if you've been installing 6mm for years, just imagine how much cable you must have wasted by installing things which are actually far too big. Now, this is the on-site guide. Just have a quick look in here, and we can see at the bottom here this is section number 7, table 7.1, which has got a list of various circuits you can use. Certainly not all of them, but certainly the majority. And we can see down the bottom here, 30 amp rating device, BS3036 fuse, and we can see there the cable size of 4 square millimeters with a 1.5 protective conductor is not permitted, and that's because of that correction factor. So for a 30 amp fuse, a rewirable type, minimum cable size is 6 millimeters squared, or square millimeters, depending on whether you want to say it whichever way around. Method C, which is by far the most common, certainly domestic properties, and then you've got the various links you can have there. Again, none of those are going to be a problem in pretty much any domestic installation. And if it was one of these other installation methods, then you would need to increase the size of the cable, but again, that's pretty much the same anyhow. Method C, by the way, is by far the most common. That is clipped direct, so cable just clipped onto a surface with suitable clips or whatever. Method C also applies for things where the cable is buried in the plaster. So again, that's very common in domestic properties, and it will also apply where the cable is sort of under the floor, hanging in the air or whatever, or above the ceiling. So method C is by far the most common. The others here, which is things like 100, 102, whatever, that's where you've put it in plasterboard with insulation next to it, and various other things you would generally want to avoid. So for that is 6 square millimetre, if we look on the next page, 32 amp protective device, so circuit breaker or RCBO, whichever type, cable size 4mm squared and a 1.5mm protective conductor, and again it's the same method C as before and the various lengths we've got there. Now of course you can put in 6mm squared, there's nothing inherently wrong with that. The only benefit that gives you is you can use some of the other installation methods such as 100, 102 and so on. But unless you've been exceptionally careless, you're not going to be routing it stuck behind plasterboard with insulation on the back or whatever else. So generally it's not necessary to use the 6 size at all. And again, you can go up to the 10 if you want to. And that's where you've got sort of cables running through insulation and whatever else. But again, that's something you want to be avoiding. And if for some reason you were putting in a circuit with a cartridge fuse, such as BS88 or what used to be called BS1361, 32 amp fuse, or it would have been 30 in the older days. Yep, 4mm again, totally acceptable with method C, similar lengths to we've seen previously. So that whole thing with the 6mm 32 amp for a cooker is a load of nonsense, and it's only really a leftover from the days of rewireable fuses. Hasn't applied for several decades in terms of modern protective devices. Now the other relevant bit in the on-site guide here is H4, which is in Appendix H, unsurprisingly, and this covers cooker circuits in household and similar premises, so mainly in the home, but if you had like a smaller commercial place just had a domestic cooker in it, again it applies there as well. And it says here the circuit supplies a control switch or cooker unit complying with BS4177, which may incorporate a socket outlet. The rating of the circuit is determined by the assessment of the current demand of the cooking appliances and cooker control unit, socket outlet if any, and that's in accordance with those other things. But the most important bit here is a 30 or 32 amp circuit is usually appropriate for household or similar cookers with a rating of up to 15 kilowatts. Just remember that figure there. And then there's some other rules here about you can put various different ratings in as well. And other items. Now remember it said 15 kilowatts. That seems quite a lot, doesn't it? In fact, whole houses can be supplied with less. Now, the standard supply voltage in the UK is 230 volts. In reality, it may be higher than that, but that's the voltage we're going to use here. And to convert kilowatts into amps, then it's one divided by the other. So that's going to be 15,000, which is obviously the kilo part of it. So 15,000 watts divided by 230 volts. And the answer to that is approximately 65 amps. Now, pretty obviously, 65 is a lot bigger than that 32 amp circuit breaker that we would have on our typical circuit. So how can this be possible? How can we get 65 amps out of it? And the simple answer is a word called diversity. Now, we've seen diversity in other videos, and the whole principle of this is that although your cooker or whatever else appliance may well have elements in it which add up to something like 15 kilowatts or whatever, the reality is they're not all going to be turned on at the same time. And even if you did turn them all on at the same time, so you got 4 boiling pots of water and stuck them on the top and cranked those to maximum, and then you put a big turkey in the oven and cranked it to maximum, and then you put the grill on as well and put loads of stuff in there. Initially, yes, these things would probably add up to quite a lot, but the reality is after a fairly short time, those elements are going to start turning on and off, because once the thing has got up to any kind of temperature, and certainly in the case of the rings on the top, that could literally be a number of seconds rather than minutes, it's then going to start regulating on and off, and they're all going to start turning on and off in various random sequences. So at any particular point, it's extremely unlikely that all of them would be turned on simultaneously. So overall, the average load, although in theory is going to be 15 kilowatts, the average over, say, a period of 5 minutes or 10 minutes or whatever is going to be considerably less. So although 65 amps sounds like an awful lot, it really isn't going to be 65 amps in any kind of practical situation. It is going to be considerably less than that. Now, Appendix A is what deals with diversity and maximum demand. We have done a video on this before. And while some of this is rather out of date and could do with rewriting, the part about cooking appliances is pretty much the same now as it ever was, because in terms of loading, cookers haven't generally changed a whole lot. So here we've got household cooking appliance, and the column here is the current demand to be assumed. And we've got the first 10 amps of the rated current, plus 30% of the remainder of the rated current, and adding on an extra 5 if there's a socket outlet incorporated in the control unit, which there may or may not be. Generally the case in more modern kitchens there probably won't be, but you can still buy those things and fit them if you want to. Now, using the information we got there, I'll just do an example here using a fairly typical cooking appliance. This could be a freestanding electric cooker, or it could equally be a hob and separate double oven. So electrically there is really no difference, it's just that they're in two separate things rather than all in the same cabinet. Now, let's just start with the hob, and this is the deal on the top where you put your saucepans and things. Typical electric hob, and this really applies whether it's ceramic or it's got the odd coil rings on top, which are really unpopular now, or the induction variety and whatever else. Typical rating for a hob is in the region of 7 to 8 kilowatts. The individual rings generally are slightly different size, some are bigger than others, but overall you're looking in the region of 1.5 to 2 kilowatts each. So in this case we'll take the 8 kilowatts being as the maximum. I say it's an old type one with the solid plates that go rusty and pitted after 3 weeks. So 8 kilowatts for that. Now an oven, which in a freestanding cooker would be the compartments underneath. These days a typical fan oven would have an element somewhere in the region of 2 to 3 kilowatts. They're usually ending up in the 2 kilowatt plus range now. 2200 is fairly common, and for this example we'll assume it's going to be the 3 kilowatts old style, fairly overpowered job. And if you've got a double oven, it's going to have another one of those, so we'll assume that that's also going to be another 3 kilowatt job. Again, in reality it might not be, because it could be a smaller oven with a smaller element or a grill or something like that. So we're going to assume that it's 3 kilowatts as well. So total apparent power then is just these three things added together, which if we add those up comes to 14 kilowatts. Now 14 kilowatts is certainly quite a lot, so if you took your typical cooker and said, oh dear, this is way over the top, because 14 kilowatts at say 230 volts, one divided by the other, that comes out to around 61 amps. So you've got a 32 amp circuit. So it doesn't appear to fit there, which isn't particularly useful. However, we can use what's shown in the book there, and this will come out to a wholly different answer. So we saw there that the current would be 61 amps in total, allegedly, if we add it all up. However, use what's in the book, we've got the first 10 amps of that current, so that's going to be 10 amps. And then it's 30% of the remainder of the remaining current. So what's left after that, the remainder is basically 61 minus 10, so that will be 51 amps, and we're actually taking 30% of that. So 30% of 51 is 15. That's actually 0.3, which is somewhat annoying. Now let's just say it's really worst case scenario, and we also had a socket outlet on it as well, so it's suggested there we want to add another 5 amps. That's for our socket. Although that's a 13 amp socket and you could plug your 13 amp kettle in, again it all fits in with the scheme of things because the kettle is only going to be on for a couple of minutes or so at a time, so averaged over a period of time it's not going to be 13 amps overall, and in fact in reality it's probably going to be a whole lot less than 5, but we'll use what's in the book anyway. So our total amount of current then is basically those three added together, so the 10 amps to start with, 30% of the rest, which is 51, times the 30%, and 5 amps at the bottom. So the adding those three together then we get a total amount of 30.3 amps, which of course as you can see is considerably less than 32 amps. So that's how it actually works. And bearing in mind that was with a socket outlet, if we had a appliance which was more powerful, then we would probably have to delete the socket there, but of course then the power will be added back in. So that's where you can put a big fat heavy duty oven or cooker or whatever else onto it, because initially the current is far more than the 32 amps, but once you've applied the diversity as described in the book, it's come out as quite considerably less than that. So if you've got that standard 32 amp circuit, which by far is the most common, as I saw in the book there, that will actually cater things up to about 15 kilowatts without any problem whatsoever. So it can be a whole all-in-one thing. Freestanding cooker, could be the ovens and a separate hob there, and of course you can have all kinds of other combinations such as the small hobs with only 2 things on the top, so you could have a couple of those and say a couple of single ovens somewhere else, or you could have say a double oven and maybe a couple of single ovens as well and not bother with a hob because it might be a gas one. It doesn't really matter what you've got, as long as the total of all of these adds up to 15 kilowatts or less, then your standard 30 amp circuit is going to be absolutely fine. So there's no need to put sort of 2 cooker circuits going into a normal domestic kitchen, Totally pointless, because under the using of this, 2 of those would of course deal with up to 30 kilowatts of cooking. I can guarantee there are no domestic properties anywhere that have anywhere near that much, because it's simply not required. So just think carefully before you put in these things, and of course bearing in mind that unless you're going to put in the cables in insulation or whatever else, for a 32 amp circuit, 4mm squared cable is perfectly fine, and that's generally going to be that twin and earth or twin and CPC or twin and skin type of cable that's quite popular. So 4mm cable, 32 amp circuit, 15 kilowatts of whatever appliances and things you may have stuck on the end of it. So there's no need to put anything else in there. And the final point is, what type of cable would you connect these things to? Bearing in mind you've got that 4mm twin and earth coming out of the wall, generally some kind of connection plate. What's the appropriate type of wire or cable to use for these? Now, in the past, a lot of people have just used your freestanding cooker and put a bit of twin and earth coming out the back. That can be used, but unfortunately it's not really designed for things that are going to be moved about. Freestanding cookers do get moved about, or at least they should, because some people do like to clean behind them occasionally. Obviously, if you're the kind of person that just sticks it in and uses it for 20 years with no cleaning, it probably doesn't apply to you. But on the back of these, bearing in mind we've got 4mm cabling in the actual circuit with the 32 amp, so for a freestanding electric cooker, 4mm H07 flex is a nice choice. That's heat resistant, generally rubber as well, so it's quite resistant to oil and grease and other such things. So 4mm H07 flex. H07 is also considered more robust than the other kind you'll find, which is H05. Electrically it's similar, but the insulation on the H07 is much more robust and therefore more suited to things that are going to move about. Now for something else like a single oven, that's typically going to be around a 3 kilowatts kind of rating, but you can still connect this to the same 4mm circuit. You could use a 4mm flex just the same, but what you can also use is 2.5mm, the same H07 flex there. Now before we get too horrified and say what's all this 2.5mm on a 32 amp circuit, well, just a minute here, because isn't this exactly the same as a ring final circuit where you have a spur coming off to your socket outlet? Yep, 2.5mm again. So this is again perfectly acceptable. The reason it's acceptable is because there's no way that this can overload the circuit or overload this cable. This is a 3 kilowatt load, so that's in the region of about 12.5 amps or so, say around 13 or something, well within the capabilities of 2.5mm. So an oven in itself is just a heating element. There's no way it can overload this. It's not going to suddenly start drawing instead of that and draw sort of 30 amps instead. That's absolutely impossible. So all you're protecting against, essentially, overload has gone away, so it's just fault protection you're looking for, and it just happens that 2.5mm on a 32 amp MCB is in 99.9% of cases absolutely fine. That's also why you can use it on a ring final circuit as a spur with a socket on the end of it, because again that's generally limited in the region of 3 kilowatts. If it was a hob, again the same kind of thing applies. The 4mm would do for that one because that's rated up to the 32 amps of the circuit, so absolutely fine. If it was only had the 2 things on it, you could use a smaller size if needed. Some hobs of course come with flex attached already, so you of course use that, and some ovens do as well. And for the double oven, again depends on the rating there, but generally either the 4 or the 2, depending on the rating of the particular appliance that you've got. And so flex is a much better choice. It's much easier to actually get around the back of there, and of course by being flexible it's designed to cover things where people are moving the appliance out to clean behind it. Now I'm sure you've probably seen in some areas or places that people have either done or decided it's a good idea to put these in 32 amp circuit, and then because you've got 2 ovens at the end of it, let's put a little mini consumer unit in the kitchen with a 16 amp circuit breaker in each one. That is a complete load of nonsense. Those 16 amp circuit breakers are going to do absolutely nothing. Bearing in mind that if you've got a 16 or a 32 amp circuit breaker, if there's a short circuit fault, then it's anybody's guess as to which one is going to go first, because they're both going to cover the situation perfectly well. And in terms of overload, yeah, the 16 is going to trip first, but again, where's your overload going to be on a 3 kilowatt heating element? Well, of course it's not going to happen. Heating elements don't suddenly transform and mutate into ones that draw more power, so completely pointless putting that at the end of it. All you need at the end is either an outlet plate in the case of a freestanding cooker, another outlet plate in case of an oven. If you've got two ovens in there, then you just get a dual outlet plate, which has the one wire coming in from the circuit, two on the outlet for the two appliances. Some ovens have a plug on them, in which case just put a single unswitched socket on the end of it. Double ovens generally wired directly, as do hobs, but again you can get some induction hobs now which just plug in, so again just put a single BS1363 socket there. All of those are perfectly fine and valid choices. You do not need to put any other protective devices at the ends, and certainly putting a little consumer unit at the end with two 16s in it is completely pointless and unnecessary. So that's cookers and cooker circuits and what you can stick on the end of them, and all the information is of course in the on-site guide. This is the 18th edition one, but it's the same in all the other versions as well. This hasn't changed in ever, so it's nothing particularly new about this. And if you're going to put one in, 32 amp circuit, pretty much the standard deal for virtually any combination of cooking appliances in various types of homes. And 4mm squared cable is perfectly fine in virtually all cases, unless you're going to start putting it through insulation and other silly things, which you shouldn't be doing anyway. And unless you're going to start putting in rewirable fuses in 2020, which of course you're not going to be doing, then you don't need that 6mm cable at all. That is just something left over from many decades ago when rewirable fuses were the standard deal. And in terms of what's on the end of your circuit, outlet plate, twin outlet plate, socket and an outlet plate, two sockets, or whatever else happens to be appropriate for the appliances you've got. You don't need to put 16 amp circuit breakers at the end or mini consumer unit in the kitchen and all this other rubbish. Totally unnecessary, achieves nothing, because again, a fixed appliance like a cooker, heating element, there's no overload protection required, because how can a heating element overload? Well, of course, it can't. It's not going to suddenly mutate into a 6 kilowatt one when it was a 3-1 to start with. So all you're covering is the short circuit protection. 2.5 is perfectly fine on a 32 amp circuit breaker for that. Same principle as a ring final circuit with a spur coming off as a single 2.5mm cable. In that particular case, short circuit protection covered via the circuit breaker, and in those ones the overload is covered via the socket outlet because you've got fuses in there. But say of course an oven or whatever else is a fixed load anyway, so it's not going to cause an overload in any circumstance. So that is pretty much it for this video, and until next time, thanks for watching.